Hi, good afternoon, everyone. I'm Marcus Weisgerber from Defense One, and thank you for joining us for the final event in our State of Defense series. Today's event, the State of the Air Force. Today, we're going to be talking about developing new technologies for aircraft and reducing the strain on the Air Force's aging fighters, bombers, and drones in a session called From the Factory Floor. And we encourage all of our audience today to participate. So you can do that on your screen. On the right side, you'll find a chat box. There you'll be able to ask our panelists questions and chat with other attendees. We'll be taking audience questions toward the end of our program, but I encourage you to pass them along as they'll get sent to me, and perhaps I could weave them into our discussion before we get to the dedicated Q&A session. So now, right before we begin, and as I just told our panelists, we're kind of the warm-up back for later this afternoon when Air Force Chief of Staff General C.Q. Brown will be joining us. But first, we're gonna have a lot of fun. We're gonna be talking about advanced aircraft concepts, hypersonics, and a whole lot more. Our first panelist today is Jeff Babione. He's the Vice President and General Manager of Lockheed Martin's Advanced Development Programs, better known as the Skunk Works, and he's got perhaps the coolest title in the world as the Chief Skunk. He's got a background in program management at Lockheed Martin, and he's most recently managed the F-35 program over his 28 plus years with the company. So Jeff, thank you for joining us.
Thanks, Marcus.
And then we also have Dr. Michael Smida, who is the founder and chief product officer for Hermeus, which is a Georgia-based startup that's working to develop the world's first hypersonic passenger aircraft, which is super cool. I've gotten to know Michael and some of his colleagues a little bit in the last few months. He's going to talk to us a little bit about the work they're doing and how they're backed by the Air Force itself and a number of other private investors. Before he was with Hermeus, he was at Generation Orbit, and he also was at SpaceX working on the Falcon launch rocket there. And to kind of maybe tie our two guests together, Rob Weiss, the former Chief Skunk, Jeff's predecessor, is actually on the Hermeus board. So, Michael, thank you for joining us too.
Thank you for having me. It's an honor to be here.
All right. So, Jeff, let's start off with you. And as I told our panelists, I always like to start these events with business executives off with talking about, maybe something a little bit different that they're doing than they were doing, a month ago, a year ago, or 5 years ago. And I know, Michael, that doesn't count, I guess, for Hermeus, the 5 years ago. But maybe, Jeff, when we start with you, let's. You're both from research and development organizations. Understanding the vast majority of the work you do at Skunk Works is classified, and we're obviously not going to be able to get into the fun stuff unless you really want to tell us. Talk to us a little bit about how Skunk Works has changed and evolved since you've gotten there about a year and a half, or about 2 years ago, and then maybe even looking back a little bit further over the past decade.
Sure, Marcus. Really, for almost 8 decades, the Skunk Works has been synonymous with some of the most advanced aircraft in aviation history. And I often like to say, if Kelly could walk the halls of the Skunk Works now, he'd be very happy. As for the most part, the things that we do, the challenges that we face and solve, are very similar as they were when he started the company almost 80 years ago, 1943. But how we do it has changed significantly, to your point, particularly in the area of automation. If you were in our factories 5 years ago, it's unlikely that you would have seen any level of robotics. Now, it's really fundamentally of what we do. So where before you may see a lot of artisans and engineers working on an X-plane, much like the X-plane that I have behind us, X-59 is NASA's next X-plane. Today, you would just as likely to see robots assisting them. In fact, we did use robots to drill a significant portion of the assembly on the X-59, something that you would never have done in the past, given the cost of entry for robotics in the past. It's come down dramatically, and now they have robots that are highly flexible and allow them to do many, many tasks rather than having to do that specifically on one program. From a business standpoint, it has changed dramatically over the last 80 years. from an area that was primarily focused on advancing the technology. I have a larger play in the overall business of the company, that being Lockheed Martin in general. But at the core, we still focus on that key innovation being the cutting edge for the company. I just have to do it in a FAR 5000 base environment, something that Kelly certainly didn't have to go up against. So much of it's similar, the innovation, the desire to do great things for our country, but in a significantly different business environment.
Great. And we're going to unpack a few of those themes you talked about with, in terms of like the new technology you're using to construct aircraft a little bit later on. Michael, why don't you tell us a little bit about Hermeus and that engine that you have behind you?
Yeah, sure. So Hermeus, we're building Mach 5 aircraft. We're a venture-backed company, so we raised a seed round in early 2019, the scope of which was to go build a Mach 5 engine, right behind me here. A lot of stuff that didn't do, but essentially showed that we as a company could go build an engine that's capable of flight at high speed, that the engine cycle works, which we knew, but still needed to show. And then kind of de-risk the entire business plan enough that we could go raise more venture capital later, which we did this past October. So we raised a $16 million Series A, the scope of which was essentially to scale up this engine to something that we could go fly. This was very much a ground test article. You can see it's got tubes and it's pretty heavy and not something that you would go fly, and also not a scale that you can fly. It's about maybe 10 inches around. But now we're pretty laser focused on scaling this engine up, wrapping an airframe around it, and going to demonstrate high-speed flight.
Great. And we'll unpack a little bit about that later and talk about your partnership with the Air Force and kind of how that's assisting with your development. It's a very unique partnership that it's been part of the AFWorks, the Air Force incubator, if you will, to get startups more involved with game-changing technology involved in the defense space. Jeff, let's shift back to you for a moment. One of the things that we hear a lot now from CEOs quarter after quarter is this kind of boom in classified programs in terms of, and research and development programs. Again, understanding you're probably not going to be able to talk to us about exactly what you're doing, but can you give us a sense of how your workload has changed or shifted in the last few years?
Yeah, quite simply put, Marcus, it's exploded. We've grown by more than 3 times in total staff, really expanded our footprint from primarily Southern California and Fort Worth. We're expanding our operations in Marietta, Georgia, all in support of some new classified programs and the opportunity to win future business. I'd say, as Michael knows, this can be a bit of a sine function. Sometimes we're up, sometimes we're down, and that's certainly the way the Skunk Works has expanded and contracted over its last 80 years. So much of the early 2020s, right after we won F-35 or 2001, we were relatively small as we began to prepare and win the next. And that's really what happened in 2018 and 2019 that allowed us to significantly grow our operations. We just opened up a new flexible intelligent factory in Palmdale, 220,000 square feet of the latest, most intelligent factory that's really almost without peer within Lockheed Martin, that'll enable us to do some of the things that we've been talking about, everything from hypersonic vehicles to unmanned systems to perhaps even various kinds of weapons. So really, given where the Department of Defense has been, the demand in hypersonics, much like Michael, in that same space. It's going to revolutionize, whether it be what he's trying to do with personal transportation or what I'm doing with some of the weapon technology. It really will dramatically change the way we operate, whether it be in a commercial or defense world. Same time, advances in computing technology and artificial intelligence, augmented reality, it's really brought a new aspect to unmanned systems that probably didn't. We're moving from autonomy to really autonomous, and systems that take and react to their situation in real time. So it's really been a unique time in the Skunk Works history where we've been able to take advantage of things that were really good in the past and now apply them to our customers' toughest problems. And that's has generated an opportunity for us to expand significantly from the West Coast to the East Coast. Challenge always is for an operation like this is how big can you get before you lose that secret sauce that made you so good? And so that's something that I'm cautious about. I always think about in my head, what would Kelly do? And make sure that we continue to focus on the things that we really excel at, and then we provide, we spin out those technologies, much like we did with the F-22, the F-35, so that some other part of the business can, and that does a better job at scaling to those large projects. So that's kind of an area that we're at right now.
Your comments remind me of something I remember us hearing a lot, maybe in the last 10 years or so, with special operations. With the growth of special operations, how much do you grow before special operations isn't so special anymore? So it's interesting to hear that perspective from the development side. Michael, you also have a new factory, from what I understand. Can you tell us a little bit about that, and also maybe talk to us about the strategic financing arrangement with the Air Force? It's I believe it's the largest strategic financing agreement the Air Force has ever signed with a company. Tell us a little bit about that, and where how that's going to help you in your development to eventually get to a commercial hypersonic airliner.
Yeah, sure. So our factory is not nearly as large, about 110,000 square feet, and quite frankly, having just moved in, it's mostly empty at the moment. But we are slowly putting stuff in there and converting it to a space where we can go build aircraft. Yeah, right now we're kind of in the midst of building up our larger scale engine. We actually also have a test site out at the airport on the north side of town, Peachtree DeKalb, where we're doing all of our sea level static testing. So that facility has been commissioned. We've gone through our first turbojet characterization test campaign. So that's rolling as well. But yeah, it's been pretty exciting. We're also starting to exercise kind of the machine that builds the machine. So exercising the design build test kind of machine that we have at the company. So we're working through a manufacturing pathfinder for the airframe, kind of in parallel with the engine development. And that's coming together, and I guess stay tuned over the next several months for some more news there.
Perhaps, yeah. Hey, can you walk us through a little bit about your two aircraft? You have the larger passenger aircraft, which is still many years away, but talk to us about the prototype that you're building now as part of this Air Force initiative. And tell us the significance about one thing I know that when we first started having conversations a few months ago that I didn't realize was that reusable hypersonics is a big deal, and in that traditionally the development of hypersonics has been to develop a weapon that at the end is expendable, that blows up, hits something, or is not used again. Talk to us a little bit about that.
Yeah, so weapons technology and high-speed things that have one-way trips to the bad guys, that's a very different technology set. So from a technology standpoint, obviously there's some similarities. A lot of the thermal problems are similar or related, but really if you're building an expendable vehicle, you make very different design decisions than making a reusable vehicle. So I guess about our passenger aircraft first, and then back to the demonstrator and the StratFi. We've kind of looked at passenger flow, pre-COVID passenger flow, because God forbid we'll be on the other side of this by the time we're ready to build passenger aircraft. And we looked at passenger flow over routes that are over water, because we didn't want to have to rely on any regulation being changed. Jeff's got the X-59 there, NASA program to go understand kind of low boom technologies and understand kind of public perception of those things. But I think eventually the regulations will move towards a more metrics-based approach. So maybe there's a chance that we can fly over land one day, but not kind of including that in the business case at this point. But if you kind of do that optimization problem, look at kind of how we model the development costs for an aircraft like this, the size aircraft that comes out is about 20 people plus or minus a little bit. So a lot smaller than you'd think of for a commercial aircraft, but you can also service 5 times as many seat miles per unit time when you're flying at Mach 5 versus kind of the status quo right now subsonically. So it kind of trends towards a little bit of a smaller aircraft, and that also, as Jeff, as things get bigger, they get quite a bit more expensive to build and manufacture. So that all kind of plays in, and that's kind of the size aircraft that we've targeted. So the general idea is across the Atlantic in a single hop, and across the Pacific with a stop either in Hawaii or Alaska, depending on kind of how you're getting across the Pacific. So yeah, that's kind of the vision, long-term vision for the company. We want to upgrade the human transportation network really, and do that with high-speed aircraft. So that's kind of the guiding light that defines a lot of the decisions that we're making along the way. So I guess move back, that's probably 10 plus years down the road, kind of fast forward in reverse to today. We're pretty laser focused on a demonstrator vehicle that we're calling Quarter Horse, named after the American quarter horse, a sprinter, and also was used pretty heavily when we were out exploring the western part of the country. So kind of on the frontier. We like to think that we're kind of on the frontier of certain parts of aerospace. So yeah, Quarter Horse, it's a demonstrator. It's really a flying testbed for the engine. It has 2 high-level goals, and everything else we've kind of left ourselves the design space to work within that. So objective number 1 is touch Mach 5. So there's no cruise time baseline, no payload bay required, although realistically we're going to want to fly things for ourselves. Other customers are probably going to want to fly things. So we're including a fixture bay, if you will. So touch Mach 5 and be reusable and have some level of reusability. I think once we fly Mach 5 and get the vehicle back, we'll learn a ton. Certainly like that at SpaceX. As soon as we landed one rocket, we learned so much, made so many changes, and kind of iteratively rolled those changes into the vehicle. And we've kind of taken a similar new space, maybe something you think of more traditionally when developing software, kind of an iterative approach where you're constantly rolling in upgrades and changes and the latest technology as it becomes available. So touch Mach 5, be reusable. And that's kind of the focus of the strategic financing with the Air Force. I'd mentioned that we raised a private round of capital to scale up our engine. And then this partnership with the Air Force allows us to go take it into flight and mature the airframe side of that and flight test the engine.
And that Michael, I see a scenario where my low boom airplane can take you to one of the cities on the coast, and they hop in your hypersonic to go over the water. Now that's moving.
Yeah, different parts of the network I think will start to interact differently. And then there's the whole urban air mobility, kind of solving the last mile right. problem. And yeah, I think all these different technologies will come together in perhaps foreseeable ways, but I think there will be things that kind of develop that we can't really know until we have the tech out there and people start using it in different ways.
I want to get to Jeff, but just in 1 second, give our viewers a sense of how long it would take a person on a hypersonic airliner to get from, say, New York to London.
Yeah, New York to London in 90 minutes is kind of the tagline. At Mach 5, it's about a mile a second.
That sounds good. We could have all been together for lunch, and went our separate ways, and or we could have gone out to see Jeff in California today, very easily if this existed. But then again, not over land, I guess. So anyway, maybe one day. Jeff, let's go over to you. I want to talk about a type of technology that there's been a lot of emphasis on of late, particularly by the Air Force, and that is digital design. Now, I suspect that, and I know that companies like Lockheed Martin have used digital design for a number of years. But talk to us a little bit about what that means for the process of design of your designing. And perhaps I'd like you to maybe touch on something that you brought up yesterday when we were doing our prep call. I know you've referenced Kelly Johnson several times, the Skunk Works founder, about how you're kind of breaking one of Kelly's rules right now.
Yeah, without a doubt. So we often Michael probably see the same thing when we talk about digital transformation, digital engineering. People like, hasn't engineering always been digital? I was using CATIA, which is a design tool when I graduated in 1985 from Virginia Tech. So digital tools have been available for many years. That replaced the CAD systems. But the difference now is between the computing power and I think the advent of some sophisticated applications. It allows us to put all the information we need to do everything from a proposal to conceptual design to detailed design to production, even post-delivery support of a vehicle in one single model. And when I started, let's say in 1985, I was a structures guy. If I made a change to the structural aspects of the airplane, then someone else would go do an analysis, make their own model that says, how did that change the aerodynamics? And based on the aerodynamics change, there'd be loads change, and then that would come back to me. And all that was done kind of in a separate way. Well, now we have the ability to integrate that so that if the future Jeff was able to change something in the structure, that would basically almost automatically or without human intervention be updated in the structural model, which would then change the loads model, and all that would be done at the same time. So why do we care about that? Well, it dramatically compresses the time between concept and capability. And that's what really is driving this change. And it's something that our customer absolutely demands. Think about their own life. Everything in our personal lives has accelerated, from the ability to get information, to act on that information, to order something on Amazon and it's delivered by a drone in the afternoon, right? That's the world that our customer lives in. That's the world they want us to have our products in. Now, we're a little bit more complicated, what Michael and I do, but their expectation, I think, is consistent with ours. And so how do we do that? Well, digital transformation is one way of doing that. As a corporation, Lockheed, we've invested over $2 billion in changing virtually every process. And you can't just take an existing analog process and put it into a digital machine and say it's going to be better. You'll be no faster than you were before. You need to optimize it for that environment. To Michael's point, change it, update it continually to make it better, even perhaps let artificial intelligence, machine learning help it optimize itself. That's where you're really going to unlock the power. And not only does that help us work within the team, say within Lockheed Martin or part of our supply chain, but our customer is there. And that's something Kelly was very adamant about. It's one of his 14 rules. Basically, the company had to own the test program, and that the customer provided the requirements, but that's when they were done. And that's just not the environment we're in now. In fact, our customer is actually in our models. So we have a design review with them. We don't put together a bunch of PowerPoint charts and brief them. They're driving around inside the virtual model, taking a look at, okay, well, what does this look like? What does the performance data look like? So really significantly changes that relationship that you have with the customer and the role that they play in ultimately the design that you have. And that's something that certainly was different than when Kelly was driving the ship back in 1943.
As you mentioned something yesterday that I took away, and I read a little bit about this online yesterday, that Kelly used to go around with a suitcase with his with actual models. So you're not going around with that suitcase anymore. So what has it done just in sheer terms of timeline? Like how much does that help you speed up your actual development? And then I guess tangentially to that, how has the bureaucratic process and the acquisition rules, I know you referenced the FAR earlier on, has that caught up yet to where we are in terms of using these digital tools?
Yeah, I'll start with the first question, or the second question first, and really about the customer and the acquisition system. So certainly Dr. Roper with his digital Century series helped accelerate the entire Air Force and even aspects of the DoD. So now they are changing. We get a request for proposal, and being a digital platform is a requirement. So it's no longer I can do it this way or that way. I have to have these digital tools, and they have to have access to them to be part of participating in that competition or that program. So they have changed, but they do recognize that there's more to change. And so I think we've done a good job on the upfront. So for conceptual design, the detailed design, to even manufacturing. Where we haven't caught up, and Michael will face this in spades, where the real tough part comes is in flight test. So how do you flight test faster? Well, you can't eliminate flight tests, but how do you smartly test? And that has been a challenge for decades. Many of the systems that we design and build, you can't actually flight test them in a realistic environment, certainly not in the environment of a war, let's say. But our tools have gotten much better. The ability to do computational fluid dynamics, even in the realm that Michael and his team are working in, is much better, but you cannot replace flight tests. And I think that's where the opportunity ahead of us is. We'll get to flight test faster. What do we do using these new digital tools that will enable us to go through flight tests faster? So only testing the points that we absolutely need to. In the DoD side, you have a separate agency that actually has to certify that the vehicle or whatever you're testing, weapon, is ready for use. That's a dedicated IOT&E, and that's something that our customer is going to have to work through. But you asked about the speed. One metric that we look at is the hours per pound. So how long does it take to build something based on its weight? It's just a parameter that's commonly used in aircraft design. And we're seeing a 2/3 reduction in the time to build something. And that's dramatic. That not only compresses the time, obviously, but it reduces the cost, which then enables you to put more inside your factory, ultimately pass lower costs on to the customer. So we're really starting to see some tremendous gains in the speed and ultimately reducing the cost of the assets that we're making.
Mm-hmm. Great. Michael, maybe you could talk to us a little bit about, I know when we chatted yesterday, we talked about the dual use technology, kind of like you were mentioning, the hypersonic reusable aircraft got viability both for a commercial industry and for the military. Can you also, I have another question about the StratFi as well. As part of that, does the military, do they own a piece of the company? Do they own a piece of the technology, the IP, or are there essentially no strings attached?
Definitely not no strings attached. In terms of the development, that's primarily commercial, so that has implications there. But the deliverables are related to test data and reporting. So there is a line there, and there are certainly things that we have to deal with in the FAR and in the contract. So definitely not a no strings attached, but I think the construct is one primarily of partnership, not necessarily just buyer and producer. So yeah, you're right. It's a very different construct than I think a lot of defense contracting has been. And the aim there really is to bring in a lot of companies that wouldn't otherwise be working with the DoD, or maybe are setting up their company a little bit differently. So in terms of dual use, we kind of saw a couple of things coming together. The technology to build a Mach 5 aircraft is relatively mature at the component level. So we're dealing with ramjets, not scramjets, which are quite a bit harder. Not science fiction, but significantly more challenging. And then on the material side, we're not dealing with large scale CMCs or anything. We can use commercially available metallics pretty much everywhere. Maybe some judicious use of the really high temperature materials. But that kind of puts us in a technological risk posture that's consistent with some of the financing that's very recently become available for kind of these big swing aerospace projects. I don't think 10 or 15 years ago, venture capital would be going into a company building high-speed aircraft or building rockets for that matter. But that landscape has changed quite a bit. And then, we kind of talked about the sine wave, kind of the fits and starts of various aspects of, I guess, Skunk Works, but different parts of aerospace more generally. And hypersonics is kind of notorious here. But we also saw very recently that China and Russia have been making making progress in these technology areas, and things that go fast are becoming a bigger part of their strategy. So I think this time hypersonics is here to stay, and all those things kind of coming together we couldn't not go do this thing. So we saw this big commercial market. If you can make a rapidly reusable hypersonic aircraft that is safe and has operating costs that are allow you to wrap a business case around it from an airline perspective, I don't think anybody would argue that that's a small market. There's this huge commercial golden ring at the end of the roadmap. But at the same time, I kind of mentioned we're taking a very iterative approach, starting with this demonstrator, biting off a certain chunk of risk there, but obviously it doesn't have any cruise time, so they're kind of the long duration hypersonic flight risks that still exist. And we're kind of sneaking up incrementally on that. And some of the things that maybe are short of carrying people, maybe they're uncrewed platforms, maybe they have some range, perhaps some payload. With something like that, you can solve some really pressing national security problems and address some potential requirements that a customer within the government might have along the way. So from a venture capital and kind of business building perspective, partnering with the Air Force or the DoD more broadly helps to de-risk some of the tech. And there's no shortage of things that need de-risking on the way to a high-speed passenger transport. But from the DoD's perspective, they don't have to do the whole lift. There are private dollars kind of going into this technology set, helping to solve some of the DoD's problems while moving towards this longer-term commercial goal.
And Marcus, I would like maybe to extend your question to me, but in a way, Michael is really helping the customer. He mentioned about risk. What I've been almost envious to see is SpaceX's willingness to take risk, and Michael's going to do very similar thing. That's an element of the customer that I have seen move and will need to continue. If we're going to do these things that are very hard and do them fast, we're going to have to adopt a much greater risk tolerance position than perhaps we did back 20 years ago. Not that we would endanger human lives, but most of these things, at least initially, are going to be unmanned. We really need to be able to go do some of these things and find, the experiment doesn't go like doesn't mean we didn't learn anything. We just know that now something has to be done differently, right? And so I think that has been a change in the risk posture from the customer standpoint. And Michael, I think, is benefiting from that.
Yeah, for sure. I think SpaceX did a lot of ice breaking there, and there's a good opportunity to kind of move forward. And to that point, we're building several airframes of our demonstrator. We have kind of a very risk-forward, hardware-rich approach there. So leveraging a lot of the digital engineering tools that are becoming available and maturing. I guess some aspects of digital engineering, being a relatively new company, that's just engineering and how we do things. But there are some other synergies there. But kind of combining that with a hardware-rich and kind of risk-forward posture, we can get to integrated systems really quickly. And when you find those big, hairy, show-stopping problems, it's usually not something that you know about. It's when you bring all these subsystems together and start getting to an integrated system, get into flight test, get into actual soup to nuts manufacturing of this thing that you find where the real problems are. So I think kind of leveraging a lot of the digital engineering, and there's some of that's tough. At Mach 5, we as a nation haven't spent a ton of time up in that flight regime. A little bit more today than a week ago, I guess. But yeah, there's only so much flight data out there to inform some of the digital models. So in some areas we have to carry some more uncertainty forward, but getting to an integrated system quickly and getting into test, and then rolling those lessons learned back into the cycle and updating our digital tools and kind of getting that iteration going is pretty key to kind of how we're approaching things. And Jeff, to your point, I think the DoD customers that we've been talking with have a much greater appetite for that than might have been the case a few years ago.
Right. That was actually my next question for both of you. What is it allowing that? What is enabling this risk tolerance? Is it guys like when Roper was there giving out awards to people who failed at something, or is it just this overarching need to kind of move quicker? And before you answer that, I want to also remind our audience that we have about 10 minutes left, and if you have any questions, please ask them in the screen. I have a few, which I'll get to in just a few minutes, but apologies. Go ahead. Jeff, maybe we'll go to you and then Michael on the risk tolerance.
Yeah, I think it's a combination of them having seen it done differently and saying, well, okay, I think we can do this. So it's not every risk is worth taking, and no risk will never get you there. So finding that the right risk balance, I think, is something that is starting to occur based on experience. But I also think they recognize, given the threat, that we may have to take more risk in order to accelerate the timeline of actually fielding the component. That's my thought. Michael, what do you think?
I think you're spot on. It has been done differently, and people are seeing that. So we know that that's a viable way to go develop systems. But we also need to do things differently fundamentally. I think if you take the China-Taiwan problem as a case study, that used to be a 2030 plus thing. And I guess if anybody who was at AFA this past week, the timeline for that is moving a little bit forward. So there's a national imperative to develop technology differently and in an accelerated manner than was the case before. And I think that plays into General CQ Brown's accelerate change or lose. We have to accelerate change. Otherwise that's not a good situation. So yeah, just all those things coming together, I think, is very powerful.
So Michael, you mentioned something earlier about China's recent, I think it was China and Russia's hypersonic activities and advances. So we do have a question from the audience, and it comes from Steve Trimble at Aviation Week, friend of Defense One. He references AFA last week, which you just brought up, and Frank Kendall made some comments kind of questioning the role of hypersonic weapons, and that he wants to review the CONOPS there for the overall mission justification. Jeff, specifically to you, one, just what are your reactions to Secretary Kendall's remarks, and what does two of your hypersonic programs, Arrow and HACM, what do they bring to the table that isn't served by other Lockheed weapons such as PrSM or JASSM, ER, or LRASM?
Well, I know Secretary Kendall well, and he's a smart man, and he wants to see the data, right? And I think once we show him, just haven't had a chance to show him the operational analysis that says, okay, where are these things useful, and what is their probability of kill or their cost to kill, right? So one of his key attributes, I think he said in that, or he has said later in talking to him, is he wants to make sure it's worth the effect. So let's just make something up. Let's say a hypersonic missile costs $1 million. What else could you use for $1 million, and would it have a better effect? My personal opinion is, given the time, in fact, the lack of time that the adversary would have to avoid the system is really key. So holding these targets at risk virtually anytime, anywhere, and what I know about their endgame effectivity is exceptional. So I think we can make a case, though we'll have to show it to them, is why they're very difficult to defeat, and the cost per round at scale is relatively low. And that's what we're trying to do really with the two systems that the Skunk Works is involved with, ARRW, where we're doing the glide body, missiles and fire control. Our parent, or one of the BAs at Lockheed, is the overall integrator and the booster provider. That's one of the number one goals, is not only to do the mission, obviously, the speeds that you need, those kinds of things, but also come down the price curve. So some of the key technologies, when we're going that fast, is going to be these carbon shells, looking at how do you dramatically reduce the cost to do some of those things. So that's part of our job. But I think the system itself could be very, very difficult to defeat. And then as you move into the air breathers, where we're talking about much more cost-effective, cost per round, though you're traveling at slightly lower speeds, as Michael put it, mainly conventional materials, metallics at that point, which enables the price point to be much lower. I think you're going to see, again, with the OA analysis, the operational assessment, that they're highly effective for the cost per round.
Are you able to share, and I understand if you don't want to or you can't, what the kind of your business case for this and what the I think when a lot of us think of weapons over the last 20 years, it's been just stockpiles of JDAMs and small diameter bombs and such. Are these, multi-thousand production runs, or are they more, boutique in, the tens or hundreds?
I think the answer is all the above. Depends what the mission is. You may have relatively few for a very, very difficult mission, and then you may have great quantities for more common missions. And I can see that really, the economies of scale, right? If we can produce more, this typically reduces the cost. So I think it's what we know from our customer is they have a need from deeply buried, hardened targets to relatively soft targets. Is it a tactical system? Is it a strategic system? All these things come in and change the way you design, and then also ultimately the cost of that weapon system. So I think it's going to run the entire gamut.
And I think that comment on operational analysis extends to a lot of new technologies. Like the Air Force obviously is invested in Hermeus's Strat-5, but what would you do if a hypersonic aircraft existed, and what novel ConOps would that open up? What potentially disruptive ConOps does that open up, especially if you're combining that with other high-speed weapons, and how does that change the picture? So to your point, I think Secretary Kendall's commentary was more, we need to go see the analysis, which I think is super fair.
All right. Jeff, we've gotten a number of questions about this, and it was about a video last week that surfaced on Twitter that came up at AFA of allegedly a Lockheed facility in some shape, if you will, on the back of a flatbed truck. Are you able to tell us anything about what we saw?
I can't.
Okay. Have your security posture changed, I guess?
We're in good shape.
Okay. Let's something on supply chain. We've had this has actually come up a lot. Just Michael and I were talking about this last night. Can each of you talk about the microchip shortage and how that's impacted both your projects, both in terms of cost and just delays in actually getting microchips? Has it been as has it been as severe as, I guess another way to ask it, as the auto industry and other industries in the United States? And we start with Jeff and go to Michael.
We are starting to see effect early on. We did that as a result of the stockpiles that I'm sure were already there. We do have several systems that we have extraordinarily long lead times where we normally wouldn't have done that. And the surprising part, maybe not, if you think about the business model, it's this stuff that overlaps commercial technology where, the same stuff that's going in the cars and stuff is going into some of the servers and those kinds of things that we need. So there has been a bit of an impact. Right now, it's not been a showstopper, not yet.
Yeah, I think from our perspective, we're kind of dealing with the same issues that everyone else is. So lead times on certain components are a lot longer than they might otherwise be. I do think we have a bit of an advantage in that we've kind of arranged our company in a more vertically integrated fashion, which when you're building high-speed aircraft, just the fact that the airframe and the engine are more integrated, being able to trade across those interfaces kind of leads you to a more vertically integrated posture. If you're building the company from scratch to go do that, and that's mainly what you're focused on. So I think some of the things that we might have outsourced from a timing perspective might make sense to build in-house on that front, but fundamentally some components are just going to take a little bit longer to get, and we're dealing with that just like everybody else is.
Okay, and we have time for, I think, one more, and Steve sends another one. He says, we understand Lockheed has completed a risk reduction of flight tests for its Hawk design. Can Jeff, this is to you, can you say when you expect to run the free flight tests at or above Mach 5?
Well, thanks, Steve. But any details relative to the flight test, you'd have to ask the customer. So I appreciate your question.
All right, and that actually, I guess I would normally do another one, but we're right up on time, so I'm going to have to end it there. Jeff, Michael, thank you so much for joining us here today for this session and for sharing your perspectives. Thank you to our audience for joining us. Please stay tuned for a word from our underwriter service now, followed by our next editorial panel, Science in the Skies, a conversation on the latest Air Force technology.